Hi everyone, so we meet again in our new video. Today we're going to move on to a new chapter. The chapter is called curve fitting. So the first method you are going to learn is what we call as least squares regression. So I believe this title is nothing new to you. You have done many lab courses and I'm sure you have done a lot of graphs. You have sketched a lot of graphs in which you got a certain set of data, X data and Y data, and you come up with a graph and you need to come up with the best fit. So what is it? Least squares regression. It is actually a strategy or a method to derive a single curve that represents the general trend of the data, right? So your least squares regression or your best fit, it does not have to intersect every point. I'm sure you have known this already. You have done this many times using graph paper. And this method is used to minimize the discrepancy between the data points and the curve plotted. All right. There are two types of fitting. The first one, what we call as linear regression, and the second one is polynomial regression. So let's look at the first one, linear regression. Okay, so what is linear regression? It's all about fitting a straight line to a set of paired observations. So here, let's say you have your data x1, y1, and your second data x2, y2, and so on and so on. All right. So this is the formula. I'm sure everyone is so familiar with this formula. Y equals to A naught. What is A naught? It's an intercept plus A1x. A1 is a slope. And E here, E is actually an error or residual, which actually exists or present between the model and the observations. The model, it means the linear, the best fit, this model here, and the real observations coming from all the data. All right. So our main interest is to come up with this linear line, linear regression line. We would like to know what is the value of A naught, what is the value of A1. So in general, if you have data and you draw a graph, Y bar and X bar, and you plot the data, and you can get the intercept at the Y axis, and the slope is actually delta Y over delta X. So you can actually calculate this through drawing a graph. But without having to do that, we can also calculate what is the formula for the linear regression. Okay, so here our interest is to work out what are the values of A0 and A1 using these two formulas here. A1 equals to n times the summation of xi times yi minus the summation of xi times the summation of yi divided by n the summation of xi squared minus the summation of xi squared. Okay, so what are all these things? So n is actually the number of points. A1 is a slope. Okay, so x and your y are your data. So this one, you just need to create another column. Can you imagine you have like X column and then you have Y column and create another column for X times Y. All right. And then just do for every data X times Y. X1, Y1 equals to what? X2, Y2 equals to what? X3, Y3 equals to what? And the summation, the total, you just put it here. Okay. The total of all xi times yi, and this is just minus the summation of the x data, and then this is just the summation of the y data, and this is, you just need to create another column to make x squared, all the xi, x1 squared, x2 squared, x3 squared, and so on. So this is summation of the xi squared, and these are also the, and that is the formula to calculate the slope. And how about the intercept, which is A naught? A naught is simply y bar minus a1 x bar. So what is y bar? Y bar is the arithmetic mean of y. It's the mean. Okay, so in Malay it's called like purata. And a1 is just the slope, and your x bar is the mean of x, or purata x. Okay, so this is very simple. And these are the formulas to calculate the mean for y, and this is the formula to calculate the mean for x. Okay, moving on. So this is just to show you, you have the x bar here and the y-axis, and these are your data, your measurement data, xi and yi, and this is your regression line. So the regression line is actually the best fit that can be represent for your set of data. So let's say you have one dot here and another one data here and another one up here, another one down here, and so on and so on. So the difference between the measurement and the point on the regression line is what we call as the error or the residual error, the E that I mentioned just now. Okay? Okay, let's look at one example here, linear regression. Fit a straight line from the table below. So you have a data here taken from probably an experiment. So you have x1, 1, 2, 3, 4, 5, 6, 7, and all the y data as shown here. So the question asks you to find a straight line or the best fit for this set of data. What you have to do is just follow the equations provided just now to calculate your A1 and A0. So before you can calculate all these things, you need to come up with all these terms like the summation of the x, the summation of the y, and n. And here, remember what is n? N is the number of data. And here is 7 because we have 1, 2, 3, 4, 5, 6, 7 data. 7 sets of xy data. And then you have summation of x squared. So you need another column for x squared. So for the first one is 1, for the second one is 2 squared, 3 squared, and so on and so on. And then you also need another column for the multiplication of data x and data y. And then last one, you need to calculate the mean value for the x and the mean value for the y. Alright, once you got all these terms worked out, just substitute in the equation that I showed you previously to calculate your A1, which is your slope, and your A0, which is your intercept. Okay, so once you got all these values, just substitute in the least squares fit formula. Y equals to intercept plus slope times x. So this is the y-intercept and this is the slope. There you go. You got your least squares fit formula for the set of x and y data.